Hello, my name is Ridge Ricketts, and this is my video for our midterm for Computer Science 2100. It's the midterm coding exams. So in this, we were asked to code 5 problems, 3, 4, 5, 6, and 7. And so we're going to go ahead and start down with 3. That was the first one. And so in this one, we are given already this first thing right here. Let's go ahead and read the problem. Write a Python function, 2 quadratics, that takes in 2 sets of coefficients and x values and prints the sum of the results, evaluating 2 quadratic equations. It does not do anything else. So right here we have the function takes 4 coefficients, a, b, c, and then a numerical 1x, and it evaluates the quadratic equation given at x. And the function returns right here. It returns the result of the evaluation. So right here we have the meat and potatoes. We got 2 quadratics. We got the function, and this function takes 2 sets of coefficients, a1, b1, c1, and then a2, b2, and c2, as well as x1 and x2. And so it evaluates the 2 quadratic equations using the eval quadratic function, one with coefficients at x1, and then the other with the other set at x2. Right here, right here, and then it calculates the sum and then just prints it. And then so we have 2 quadratics, prints the sum. And so my answer that I always get is I get 96. That's what I get personally. And so that's problem number 3. That's the first one we work on. And then we'll go ahead and go down to problem 4. And so in problem 4, we are asked to implement a function that meets the specifications. So that's given right through here. Assume L is a list of lists whose elements are ints, mutates L such that int reverses its elements and also reverses the order of the int elements in every element of L. So essentially what we're doing is we're taking 1, 2, 3, 4, 5, 6, 7, and we are completely reversing it, everything. We're reversing the elements and then the elements within each of the elements. And we do eventually get 7, 6, 5, 4, 3, 2, 1. And so right here in the deep reverse function, it's only defined with L. That's our input list that we have down here. And then the L dot reverse, this line reverses the order of the elements in the main list L. The reverse method, and modifies the original list in place so it doesn't return a new list. And then we're going to go ahead and we're going to iterate over each sublist in L. We're going to use this for method. This for sublist in L, this line essentially just iterates over each sublist in the main list. L right there. And then we're going to reverse the elements in the sublist. Right here with the sublist reverse method. Inside the loop, this line just reverses the order of elements within each sublist. Again, the reverse method is used here, modifying each sublist in place. And then we establish the list, and then we have deep, reverse L, and print L. So we just use the deep reverse function that's provided up here. We use it at the end, and it creates a list of lists L and calls the deep reverse L. And then we print the statement. And then we go ahead and we get our completely reversed 1, 2, 3, 4, 5, 6, 7 to the 7, 6, 5, 4, 3, 2, 1. Now for problem 5, we have the dictionary invert. And so the dictionary invert function it takes D as its input. This one is already given. And that's to the instructions right here. And so here we have um, the inverted dictionary. So for each key pair value, the function checks if the value already exists as a key in the inverted dictionary. And so we have four. And uh, so if the corresponding values do not exist, it adds the value to the key inverted dictionary with the corresponding key from T as a single element list, essentially. That's what's happening here. And so if the value already exists, it appends the key from D to the list associated with that value in the list. And so after building the inverted dictionary, the function sorts the list of keys associated with each value in a sorted order. So that's where we get that value sort function right there. And so the function returns the completed inverted dictionary right there. And so here's our test cases right here. These are just to call the function with the sample dictionary and then print the result. And you can see right here my result that I get. It just repeats. And so here we have problem 6. So we have find max value right there for our given function. And so this one just takes a single parameter t, which can be tuple or list, either one. This is all given right here. And so we have the base case. If t is an integer, return t. So the base case is handled first. If t is an integer, we have instance t int t. And so the function simply returns t right there. And so we have the recursive case. If t is a tuple or list, find the maximum value recursively. So right here we have max value equals float int. So if it is not an integer, it initializes max value to negative infinity right there, which will lead to be used to keep track of the maximum value found. And it iterates over each element in T. And so we have 4 element in T. So for each element in T, the function recursively calls the max val element in parentheses to find the maximum value. And this recursive call handles nested tuples, diving deeper into the structure until, or, if it reaches an integer. And so within the loop, it's just updated to the maximum value of its current value and the maximum value found in the current element. And so, this just, after iterating it over all elements of T, the function just returns max value, which holds the maximum value found in T over the nested elements. So this is our print statement right here. We just use the max value that was given to us at the beginning, and it calls the function with the nested tuple and list end and just prints the result. And so I get 8 in this case. We got problem 7. We'll go ahead and read this one. Pulls up a bigger screen. So write a Python function called satisfies that has a specification below. What's given right here in orange. I'm not going to read it, but we go ahead and start with what's given to us with satisfies FL is initially given to us, define FS, and then the run satisfies function. And so right here, we have where we add in, where we filter out strings from L for which F returns false. All right. That's what we're doing right here. It filters the elements of L such that only the things S for which F returns false. And then that's what is retained. And that's what was given there. That was given there. And then we just add in our list right here, our input. And then we're going to go ahead and run satisfies FL. And this is just provided to demonstrate it. And then essentially, this input is passed into the run satisfies right there. It goes ahead and runs it, and then prints the new list. And I was able to get a output that is the same as given here, B comma C. All right, thank you for watching. If there's anything I didn't really need to explain as well, or if I need to go into more depth for the exams, go ahead and let me know. Um, just so I can know for maybe the final or whatever's coming next. But yeah, that's it. Thank you.